Geometry, Chapter 2, Section 1 Inductive Reasoning and Conjecture. So, inductive reasoning is figuring out a pattern. So, the whole idea is you look at some things that have happened, you try to establish some sort of pattern, and then use that pattern to figure out what happens next or to draw some sort of conclusion, right? And that's just where we just assume that whatever pattern we have observed just continues. It's it's a good place to start with any sort of like science, right? You look in the evidence to see what's happening, try to figure out that pattern, and then you try to test that pattern to see if it always works. A common example I always give: let's drop something. What happens? It falls. And every time you've ever dropped anything, it always falls, right? So, using inductive reasoning, what do you expect to happen? What's your conjecture, right? Your prediction about the pattern. The prediction about the pattern is whenever you drop something, it falls. Well, that's a pretty well established piece of inductive reasoning. We call it gravity. Now, is that a complete story of what gravity is? No. But it's pretty useful, and we've been using it probably since forever we've started thinking about it. You let something go, it drops. That's basically what's happening. It doesn't necessarily explain why or other things that it tells us about gravity. It just says you have something, you let it go, it falls. So that's the idea behind inductive reasoning. And sometimes the patterns hold really strong and true, like gravity, and sometimes the patterns break down eventually, and they maybe you can only predict for the next couple things, but then the pattern gets too crazy after that. So that's kind of the idea with inductive reasoning. Again, the concluding statement, or kind of like the idea or whatever you're able to conclude about the inductive reasoning, we call that a conjecture. Let's look at some patterns. Patterns and conjecture, for example 1. We're going to write a conjecture that describes the pattern in each sequence, then use your conjecture to find the next item in the sequence. So, movie show times: 8:30 a.m., 9:45 a.m., 11 a.m., and 12:15 p.m. Now, it seems like there's a new movie every once in a while, right? Well, let's figure out how far apart these movies are. From 8:30 to 9:45 is an hour and 15 minutes. From 9:45 to 11 a.m. is an hour and 15 minutes. It's also an hour and 15 minutes to get to 12:15 p.m. from 11 a.m. So, our assume is every hour and 15 minutes we have a new movie showtime. So, conjecture: a new movie starts every one hour and 15 minutes. So that's our conjecture about the sequence that we see here. Now we have to use the part where we predict the next item. Well, what's 12:15 plus an hour and 15 minutes? Well, 12 plus one more hour is 1. 15 plus 15 is 30. So the next movie time is at 1:30 p.m. Now, this conjecture is great for figuring out the pattern of movies for that day, but I don't know many movie theaters that have shows going on at 8:30 in the morning on a Tuesday. So this is probably a weekend schedule, right? So you could probably follow this pattern out, but if you kept going, eventually it would break down, right? There's probably not a new movie playing at 4 in the morning, right? That's just not a time that people are out to see movies. So you can see the pattern works for a while, but eventually it's going to break down. And that is one of the problems with inductive reasoning is it's usually good for the short term. It's more rare when it's good for the long term. But that's what you want to do here. Now, let's take a look at the next pattern. This is a little bit more mathematical. We've got these shapes that are going here, and we have a number associated with each shape. And we've got 4, 10, 18, 28, and 40. Well, what I'm going to do for each of these, what's 10 minus 4? Well, it's 6, right? So it increases by 6. 18 minus 10 is 8, so it increases by 8. 28 minus 18 is 10. So it looks like we're increasing each time, right? But are we increasing by a consistent number like we were in the last one? No, the number that we're increasing by seems to change each time. 40 minus 28 is plus 12. So here it looks like we're increasing by the next even number. There's no odds that we're increasing by. So that's my conjecture. Increase by the next even number. So if we end at 40 and we had 12, what's the next even number past 12? Well, it's 14. So I have to add 14 to it. 40 plus 14 is 54. And that's my next term.